All right, thank you all for standing by and welcome to today's webinar, Load Balancing Strategy with Nginx, HAProxy, and Consul. Please feel free to type your questions during the webinar. This webinar is recorded and the recording will be made available after processing, usually within 2 days. And our speaker today is Christoph Poi, a Senior Solution Engineer from HashiCorp. And now let's get started, Chris.
Hey, thanks, Chang, for the introduction. Welcome, everybody. Thanks for joining this webinar on load balancing strategies with Nginx, HAProxy, and Consul. So, as already mentioned by Chang, my name is Christoph Pohl. I'm working based out of Germany as a solutions engineer at HashiCorp. I'm mainly focusing on HashiCorp Consul, all the surroundings and all the integrations. Our agenda for today will be, I will run you through the main core use cases of Consul itself, just to give you a quick recap what Consul can do. Then we'll touch more in depth on Consul's service discovery features, which we are then using to show how Consul's integrated load balancing works. So without even having a load balancer, just what Consul offers you out of the box. And then I will give you some small demos on how you could integrate Consul's service discovery features and Consul's service registry to automate your existing Nginx or HAProxy or what you have load balancers. First demo will be with Consul template, and the second one will be with native integration of those load balancers into Consul's service discovery. Just to give you a quick recap on the HashiCorp mission and what we're doing as a company, basically HashiCorp and all our tools are abstracting the workflow when our customers are on their journey to a multi-cloud environment. So may it be a private cloud, may it be AWS, Azure, GCP, Ali Cloud. Our tools are there to help you to uniform your workflow from the provisioning perspective, where we have Terraform to give you a unified approach for infrastructure as code across multiple clouds. We have Vault for securing all of those different clouds as our secrets management system. We have our own runtime environment, our own scheduler called Nomad, but we also have first-class integrations of all of our tools, for instance, in Kubernetes and other runtime platforms as well. And today we're talking about Consul, which is our multi-cloud service mesh networking tool. And so why do we think we need all of those tools, especially Consul? When we see the market trends, basically in the, I would say, the former days, we had a single application server where we could map the service the server provided to the server's IP address. Now that we see more and more dynamic environments, we see container environments coming up like Kubernetes, where we don't necessarily have a mapping between the service that pod is providing and the IP address it gets from the scheduler itself. We need some more sophisticated solutions to really do networking and to do service discovery in this highly dynamic environments. So we're basically seeing a shift from a static infrastructure where we could do everything IP-based to a dynamic infrastructure where we need a more abstract layer of discovery, of segmentation based on services. The two main use cases of HashiCorp Consul are basically providing a service registry and service discovery for your applications and offering you a complete service mesh solution across multiple runtimes, across multiple clouds. So today we want to focus on the service registry and service discovery piece in conjunction with internal and external load balancers in depth, and we are not touching the service mesh part. Just to give you a quick recap how service discovery was done as up until now. Basically, when we had monolithic applications, we had like multiple processes, multiple services running in one box. So if service A wanted to call service B, it was mostly an in-memory call. It doesn't need to know where service B is, because service B basically was on the same box. Now, if services wanted to talk outside, to backend database or something. Most of the time, this was done with a static IP address, which was baked into the application itself. If we wanted to scale those monoliths, we did put load balancers in front of it. Most of the time, those load balancers were not because of the sophisticated features a load balancer can give you, like web application firewalling or something. A lot of times load balancers are just there to do service discovery. So applications have the virtual IP address a load balancer is providing, connect to it, and the load balancer takes care of spreading the load across all the available backend servers. Now, as applications are not built as monoliths anymore today, and we're talking about microservices, if now service A wants to call service B, it's not an in-memory call anymore. It's basically a call over the network. So service A needs to know where service B resides. And this can be more tricky if service B scales independently of service A. So again, what we see customers doing, even though service A to service B might be an internal east-west traffic inside of your data center, which doesn't need that high sophisticated load balancing features, people are putting a load balancer in between those services just because of the sake of service discovery. So service A has an IP address to talk to, which is the load balancer IP address, and the load balancer needs to take care of actually tracking all the backend services. The load balancer needs to be configured. So if service B scales up or scales down, these days it's mostly ticket-based systems where the application team, after scaling a service, raise a ticket to the load balancer team and say, hey, please reconfigure the load balancer. We have this and that new endpoint which serves this service. This can be cumbersome and time-consuming, and so today we want to show you how you could basically, especially for east-west traffic, automate all these things with Consul out-of-the-box load balancing, and for your north-south traffic, and where you might already have load balancers like Nginx or HAProxy in place, how you could automate those by integrating with Consul Service Discovery. So Consul Service Discovery itself works as following. As soon as a service instance of any type starts up, Consul service registers itself in Consul. So Consul keeps track of all services within your data center. Consul has a distributed health checking feature, so that Consul not only knows which service it resides at which node, it also knows if the service is healthy. Now, if service A again wants to talk to an instance of service B, it can discover this service in Consul's service registry, and Consul will provide only healthy instances of service B back to service A, and service A can connect to those instances. As Consul randomizes the answers it sends back to service A, we have out-of-the-box load balancing. So we either through our HTTP API interface or through our DNS interface, Consul will randomize the replies, and the service will basically talk to a different endpoint each time it requests a service instance. As mentioned, Consul has distributed health checking, so Consul will never ever give the IP address back to service A of an unhealthy instance of service B. Besides the service registry, which I just mentioned, which can be queried through standard DNS interface or through our HTTP API, and we have the distributed health checking features in Consul, and we provide the load balancing out of the box, which can be especially helpful when we're talking about east-west traffic within your data center, where you don't need all the sophisticated features a high-end load balancer might give you, like web application firewalling and things like that. One thing Consul offers you out of the box as well is multi-data center features. So we're not only load balancing services within a given data center. If there is no healthy endpoint within your data center, we can configure Consul in such a way that it will automatically fail over and give you a healthy service instance of the same type based out of a different data center. Now, if you have already some Nginx, HAProxy, load balancers in place, especially for north-south traffic where you might need features like session stickiness. We appreciate that, and we don't want you to get rid of it, especially when you're not managing the DNS, like public-facing load balancer or something. This is why we offer tools to help you to automate those instances by leveraging the service discovery features of Consul. The first tool I want to demonstrate today is Consul Template. So Consul Template is a standalone application that can run like a sidecar application to your load balancer. And Consul Template has its own templating language. So you can provide an input template to Consul Template with variables, which Consul Template will then automatically fill with values it receives out of Consul Service Discovery. Consul Template will then write a configuration file for you, like the Nginx configuration we will see in a minute. It renders this file, puts it in a well-known location, and triggers the application to reload its configuration. The demo setup I've prepared for you looks like this. So I have my Consul server cluster on the right-hand side. I have 3 instances of a web service running, which is registered to Consul's backend. I have my Nginx server fronting those 3 web service applications doing basic round-robin load balancing, and I have Consul Template sitting next to my Nginx load balancer. Consul Template is configured in a way that it will use a HTTP, a long-lived query, like a blocking query against Consul's API, and watch for changes within a given service. So each and every time something changes in Consul's service catalog, Consul Template will automatically get notified, and it will then trigger a new config rendering and reload the service again. And this is basically what I will demo you now. This is the input configuration file I'm using for my Nginx configuration, which is basically the simplest configuration file for an Nginx load balancer you can think of. But you will notice that within my upstream backend configuration, I don't have explicitly put in my IP addresses of my backend servers. I put in some instructions for Consul Template. So I say range service web, which basically says use all of the available healthy endpoints which offer the service web and which are registered as the web service within Consul service catalog. And out of those, use the IP address and the respective port they are offering the service on. Render my configuration, and the outcome of this will be Nginx configuration, which you might look more familiar to you guys. So then I will have my IP address in there. I will have my HTTP port in there. All right, let's jump to the demo. So what we see here is, again, the setup of my application, which we're currently working on. I have the Consul UI here, where I have my web service registered, and you see I have 3 healthy endpoints running. So to make Consul Template work, basically Consul Template needs 2 main files. First of all, we need the Consul Template configuration itself, where we tell Consul Template where to find Consul. As Consul is an agent-based system and the API is basically always on localhost available, we say, okay, the Consul API is at localhost at port 8500. We then need to tell Consul Template what are my input templates, what is the output template, and what is the command Consul Template should run after the output template is rendered. So basically, I have the input template here, which is exactly the file I just showed you in the PowerPoint presentation, which has my upstream backend configured with Consul Template variables. And I instruct Consul Template to put it in the well-known Nginx config directory for load balancer. And after this was done, Nginx basically gets reloaded, so Nginx can ingest the new configuration. I already have Consul Template running in the background. So there it is. You see console templates running, and it's using the exact same configuration file I just showed you. On the left-hand side, I'm connected to my Nginx front end, and I see when I refresh the page, it's basically load balancing round robin between all of my 3 available endpoints. The current configuration file of my load balancer basically has all of my 3 backend servers available because they're all up, they're all healthy, and Consul is aware of that. Now, if I'm connected to one of those instances down here. If I'm going to stop my Nginx, my web service down here, Consul health checking will immediately see that this node is getting an unhealthy state, as you can see here. So my 3rd web server isn't passing its check, it's unhealthy, and Consul template will immediately get triggered, render a new configuration file, as you can see here, and now I only have my 2 healthy instances in my backend server pool, and traffic is only going to those 2. Same thing is true if I restart my service. Consul health check will kick in, will mark the node as healthy, and Consul template with its blocking query will get notified of the change, will re-render the configuration template for Nginx, and my 3rd server is back online. So basically, Consul template can help you with any tool that is configuration file based, and you can easily scale up and down your backends by simply putting Consul template next to your existing HAProxy or Nginx load balancer. And due to the lack of time, I will only show the Consul template use case with Nginx and not with with HAProxy. But you could think about the exact same notion for building your HAProxy configuration file. Let's move on to the next one. There are a lot of companies who build native integration in service discovery and Consul. So do Nginx and HAProxy. I will showcase it with an HAProxy integration right here. So my setup looks nearly the same. I have my Consul cluster. I have my 3 service instances who offer my web server. I have my HAProxy load balancer in this case, fronting all of them. And what you can see right away is that I don't have Consul template here anymore. So now the load balancer itself connects back to the service discovery, to the service catalog of Consul, to auto-render its configuration based on something HAProxy calls server templates. Again, I will only show it for HAProxy, but Nginx Plus, for instance, has the exact same approach. F5 has kind of the same approach. Nginx Plus and HAProxy leverage the DNS interface of Consul. F5 has a native HTTP API integration, for instance. Right, so the difference here is that I don't have input-output template as I had it with Consul template. I only have my HAProxy configuration, and HAProxy has something called server templates. You can see right in the middle here. I have, again, a pretty basic load balancing configuration. I use round robin just so you guys see it's actually balancing the load. The server template here instructs the HAProxy appliance to build something I call my web app. I called it my web app just to make sure that it's not related to the web service in Consul. You could give it any name. I say I want to have for this server backend, I want to have 10 slots pre-provisioned in my HAProxy appliance, which means that if I'm only using, like I do, only 3 backend servers, I will only use 3 of the 10 pre-provisioned slots. If I use 20 backend servers, I will only use 10 of them. I will not be able to scale up to 20. Otherwise, I have to change this configuration. But what this 10 gives me is that it pre-allocates the memory I may be using if I'm scaling up to 10. With _web._tcp.service.consul, I basically instruct HAProxy to use the SRV DNS record out of Consul service catalog for the web service. And I tell HAProxy which resolver to use, which is in my case Consul. I say use the IPv4 addresses and put a health check on those backend servers as well. Especially regarding the health check, we have customers using this exact integration from HAProxy into Consul service discovery and not using HAProxy-based health checks. The reason for this is that we have, as mentioned, distributed health checking within Consul, and you could use other metrics with Consul health checks than just, I would say, like a simple HTTP health check HAProxy is providing out of the box. So you could check for CPU utilization, for instance, and based on that mark an instance healthy or unhealthy. I then need to define the resolver itself, so basically where to find my DNS interface. And again, as my Consul client agent is running next to HAProxy, the DNS interface is on localhost. This time it's port 8600. I need to increase the accepted payload from HAProxy, because when I'm querying for a DNS server record, the payload size might get bigger than what's per standard accepted. And for this demo, I tuned the amount of time, how often HAProxy will query Consul's service catalog for changes. This is the whole valid timer. I reduced it to 5 seconds. As per default, it would be 30 seconds, but you can tune it as you want to. So what exactly uses HAProxy? I mentioned it's the SRV record. If we're querying Consul's DNS interface for the SRV record of our service, this is basically what we're getting back. We're getting back like the service name, we're getting back a precedence, we're getting back the weight, we're getting back the TCP port the service is listening on, and we're getting back the nodes with the respective IP addresses. Especially regarding the weight, I will demo something a bit, because you could use the DNS weight configure in Consul to basically adjust the weight HAProxy uses for its load balancing. Right, so let's jump into the next demo. Again, this is Consul's UI with my 3 healthy web instances. By the way, it's the exact same server backend. So now I have Nginx in the back, HAProxy in the front, and this is the complete HAProxy configuration file. Early on, I just showed you the basic backend and the things we use to connect to Consul. Out of this, when I start my HAProxy service, which I have already done, HAProxy will render this backend configuration. So we see that I have this 10 pre-provisioned slots, which I could fill with service instances as I scale. But as I'm only using 3 of them, I currently have only 3 of them available. You see the weight is 1 at each of those backend instances, which means that each request will get served round robin. It's 1, 2, 3, 1, 2, 3, 1, 2, 3 all the time. We have exactly the same behavior here. When I stop my Nginx, my backend instance, Consul will see it with a health check. And after latest 5 seconds, when HAProxy requests Consul again, we see that my third web server is going into maintenance. And the fact for that is that DNS resolution is not there anymore for this backend device. And we have load balancing across the other 2 servers. Now, same thing again, if I start my server, Consul will see it, will mark it healthy again. HAProxy will query Consul after 5 seconds, and it will see the server is back up running. So there's one more thing I wanted to demonstrate, which is basically, this is my service configuration file. And I mentioned that HAProxy is using the SRV record. So currently my SRV record and my weights are 1 for all of my servers. Per default, DNS weights are available from 0 to 65535, and HAProxy weights are available from 1 to 265. So you need to do a little bit of a conversion if you want to basically configure your HAProxy instance based out of Consul weights, but it's possible. So if I now change my weight for this service to 265, and I reload console to basically reread my config, I will see that for my third instance here, the DNS weight has changed. Again, this will instruct HAProxy now to change the weight for this server as well, and we see the weight increased to 2, meaning that this server number 3 will now get more requests, basically doubled the requests as the other 2 servers. Right, that basically showed that with native integration, I could basically do 1 or 2 things more I can do with console template. I don't have a sidecar application, I have native integration, which might be, some people may like it more, some people may like the approach of console template more. So basically, in summary, what we showed you today is, especially for east-west traffic, if you only use your load balancers for service discovery and not for high sophisticated load balancing features like session stickiness, web application firewall, and its east-west traffic within your data center where you control your DNS, and then we have customers who really replaced a lot of their load balancing instances by Consul's native and integrated load balancing features and saved a lot of money because they don't have to maintain those load balancers, they don't have to configure them, they don't need to buy new ones. But if you already have Nginx load balancers, HAProxy load balancers in place and want to automate them with help of Consul service discovery, you can absolutely do so either through the native integrations or through help of Consul template, for instance. For future reference for you guys, I put in some links. So if you want to get more information on Consul template and what you can do with it, here's the link to Consul template. Besides talking to Consul service discovery, or to Consul's key value store, there are some interesting use cases around web servers, load balancers, with Consul template in regards to HashiCorp Vault. So for instance, you could use Consul template to request SSL certificates for your web servers, for your load balancers from your HashiCorp Vault CA, and automatically render them into files and reload your configs. There's a nice blog post from a friend of mine, Baptiste from HAProxy, who basically showcases in this blog post how you can use Consul template in conjunction with the HAProxy native integration, which gives you like a double layer of automation. We have the service discovery integration in Nginx Plus, which you can find on the third link. Just due to the lack of time, we weren't able to showcase this. And if you want to try all of this at home, I put together a GitHub repo where you can find all of the configuration snippets I showed you during this webinar. And with that, we are at the Q&A stage. Do we have any questions?
Yeah, sure. Thank you, Chris. Yeah. At this time, we would like to open it up for any questions. So please enter your question in the chat box. So the first question we get is a little bit about how Nginx or HAProxy deal with sticky sessions.
Sorry. Yeah. Client to cluster submit. Oh, honestly, I don't understand that question right away.
No problem. So for the audience who asked this question, if you don't mind, kind of elaborate a little bit in the chat box, we'll answer that one later on. So maybe we can move to the next one. I think you talk a little bit about that, but how can console load balancing do the sticky sessions, or do we actually support sticky sessions?
This is some short question is no. As console randomizes its replies when somebody requests a service IP address, and we don't have session stickiness within console out of the box. This is something that basically you could potentially implement client-side if you're in charge of the client application, but out of the box, this is a use case where you should stick with your existing load balancers. So if you need session stickiness for like a web shop or something, this is something Consul as of today can't give you.
Awesome. So another question is about where can we find tutorial to follow and learn. So I believe Chris already shared a lot of resources in the presentation, and we will share that link after we have the recording be available. But also I would highly recommend you guys to go to hashicorp.com/learn. The Learn platform has a lot of like step-by-step guidance on different use cases.
Yes,
so move to another.
Sorry, Jane.
No worries. I think there's some audio lagging on my side, and I apologize for that.
So just to give some more insights on this Learn platform, currently as an outcome of this webinar, we're working on really putting those slides into Learn tracks, which you will be able to find like in some weeks on learn.hashicorp.com, as mentioned by Chang.
Awesome. So move to the next question. If we're using Consul for server discovery for our Kubernetes service, and it is running a node port, which means every time the service will have a random port every time it restarts, will HAProxy server template be able to discover against those ports since they can now be pre-configured? Or in this case, would Consul template be a better choice? It's a very long question.
Honestly, I haven't tried it, but as you can do service registration for your Kubernetes pods, especially when you expose them on node port, I'm pretty sure that HAProxy server templates should be able to discover those ports as well as they are exposed in the SRV record of the service itself, which is used by HAProxy. I haven't tried it, but it should work.
Awesome. So next question is related to the multi-data center or multi-cluster scenario. So does Consul take the latency between data centers into account to reduce traffic between data centers?
Yes, it absolutely does. So when we're talking about multi-data center failover with Consul, it's really not the case that you get randomized service endpoints. So as long as there is a healthy service endpoint within your data center, Consul will give you only healthy endpoints within your data center. And then you can decide on a failover basis and on a service by service basis or on a catch-all rule where you want to fail over. If you want to fail over in like a specific data center, or we also have the ability to use something we call network tomography to fail over into the nearest data center based on round trip times.
Awesome. So the next question is Consul only for cloud services? This audience is running a mixture of on-prem, AWS, Azure, and Kubernetes. So is Consul a good solution for multiple runtime platforms?
Yes, absolutely. So Consul is completely runtime agnostic, I would say. You can run Consul on bare metal servers, you can run Consul on top of Kubernetes, you can interconnect all of those with our service mesh solution, which we didn't touch today. But basically, yes, Consul is absolutely for on-premise as well as cloud and multi-cloud deployments and multi-runtime.
Awesome. So next question is about, is it possible to pass values to Nginx directly via Consul, just like what you demoed on HAProxy?
To pass values for Nginx?
I think it means directly.
I'm not sure what this question is all about, but basically, if it's about the native integration of Nginx, the native service discovery integration of Nginx is only available in Nginx Plus. But I think when it's about more sophisticated configuration, this would be something which we could do with Consul template with the help of our key value store. I'm not sure if the question is going in this direction, sorry.
The next question is about whether Consul has any kind of integration with Terraform.
Yes, absolutely. So there is a Terraform provider for Consul.
Awesome. And I believe we also have Terraform providers for Consul in different cloud environment, correct? Like for Azure or for AWS, we have different Terraform providers for that.
Yes.
Awesome. Next question is how to avoid HAProxy startup service down situation when using SRV template in HAProxy.
I think this question is around how we make sure that the SRV record isn't there before the service is ready. As mentioned, we have health checking features in Consul, and with that, we can really make sure that we only return back a service endpoint once the Consul health check passed. Depending on how you implement your health check, this could be a shell script, this could be a bash script, this could be like a simple curl command, which I used in my demo. Then it's basically up to you to implement a health check, which waits until your service is ready, and then we will, after we mark it healthy, we will basically expose it via SRV record. I hope this answers the question. Otherwise, feel free to ask a follow-up.
Great. The next question is around the scalability of Consul. What sort of scale can Consul run at? Is it possible to run on hundreds of systems?
Absolutely. So we have customers in the US and France which are running tens of thousands of Consul nodes. Basically, a Consul node is either a server node or a client node. We have customers, I think there are around 10,000 nodes within a single data center, and you can interconnect those Consul data centers. So it's really for large scale deployments.
Nice. The next question is, does Consul offer a free version, like it's a free software?
Yes, absolutely. So basically, all of our HashiCorp tools are available as open source. All of the features I demoed today are available in Consul open source. On top of the open source features we are offering, we offer enterprise features for all of our products. But yes, all of our tools are in the first step open source and free.
Yeah, we always encourage you guys to try the open source feature to get started. And if you're adopting for your enterprise environment and you want to mitigate downtime interruption, or when you reach certain scale, please do look at the enterprise feature that help you to address those challenges. So the next question is also related to Kubernetes. Let me read through this question. So how does Consul handle services that are registered in Kubernetes? How can they be discovered from VMs running outside of Kubernetes? That's a great question.
That's a great question. Thank you for that. So basically, when it comes to service discovery and service registration with external services and Kubernetes, there's something we call catalog sync, where we basically have a Consul client running inside of Kubernetes, who makes sure that all services which are available externally, like if you expose a service on a node port, if you expose a service via load balancer, layer 4 load balancer, I have to say, and that those services are basically synced back to the Consul catalog, and vice versa, so that each and every service a VM is offering and which is registered to Consul gets also registered in Kubernetes, so that it makes service discovery easier for Kubernetes pods to find outside services, as well as for VMs running outside of Kubernetes to find services within Kubernetes. And also, if you think of multiple Kubernetes clusters, where you, on a per Kubernetes cluster, you have really nice service discovery within the cluster, but cross-cluster service discovery. This is something where you could use Consul's catalog sync as well to sync basically services between I would say, legacy and Kubernetes clusters. Yeah, that's absolutely possible.
Nice. And we recently released the console Helm chart for Kubernetes that help easy deployment for console on Kubernetes environment. So please to go check it out. The next question is related to multi-data center. So in those multi-data center or multi-cluster scenario, would you need a cluster for each data center, or can console cluster itself be distributed among multiple data centers? If so, would this be a good idea or not because of latency?
So basically how Consul works is Consul is based on Raft, and it's a consensus algorithm. So you always need quorum to have at the Consul server level to have Consul up and running. So normally we have like 5 Consul servers, and now if you think about spreading them across 2 data centers only, this is not a really good idea. So basically the normal deployment pattern would be to have a Consul server cluster per data center. Yes.
Yeah, and by architecture, each console cluster is its own failure domain. That means if anything happens in this like primary data center, it won't fail over. It won't affect other data centers. So if you have multi-data center, I think it's a better idea. You have like independent cluster on each data center. So the next question is about what type of volume of services and how rapidly can they be changed before the console cluster begin to have performance issues? Is there a good guide to console performance scaling? So I think this particular this audience, they're building applications that will create many small services and start and stop kind of rapidly. What issues should they be aware of? I guess they're talking about more ephemeral services at scale.
At scale. Yeah, basically this is exactly what Consul is built for. Regarding the performance, you should take into consideration for your virtual machines your Consul servers are running on. I need to refer you back to our Learn platform. I don't have the numbers out of my head, but there we have the Consul best practice architecture documented.
Awesome. I think that's all the question we have, and we are almost at the top of our time. All right. Thank you, Chris, and thank you for all the great questions from the audience. So I hope everyone enjoyed today's webinar and have a better understanding about how Consul can help optimize the load balancing strategy for your environment. And finally, as mentioned at the beginning, this webinar was recorded, and we will make the recording available on our website after processing. And I will send an email to everyone who registered with this recording link. And have a great day. Thank you, everyone, and goodbye.
Thanks, bye.